Okay, so we know that 2 is a 0 of f of x. All right, so that means, remember, this was x to the third. This was x squared. This was x. And that was just your constant. Okay, so remember, they drop down 1 once you find a 0. So this becomes x squared. This becomes x. And that becomes your constant. Okay, so we know this is one of our zeros. Okay, so now we have f of x equals, we have our x minus -1. Now we have x minus 2 times x squared plus 0x. I guess you can say that. X squared, 0x. You can leave out the 0 if you want to. Plus 3. Okay. Now the thing is, x squared plus 3, you can't factor that and get a real number. So these are actually all of your real zeros. Okay, so they ask for the rational zeros. If you solve for -3, you end up with an irrational number. So x equals -1 and x equals 2 are your only rational zeros. Okay, now if you factor this, that's your final answer. And just in case, factoring x squared plus 3 would give you x plus square root of 3i, x minus square root of 3i. Which they're not rational numbers, so that's why you can't use them. Complex, not rational. Okay, so that's why even though you have an x squared plus 3, you can't really factor that anymore. Oh, sorry about that. All right, any questions on that one? All right. All right. Somebody's still writing. So I guess all there. All right, so let's say if we do one more. Okay, so let's say, for example, what are the actual rational zeros of f of x equals x to the third plus 3x squared minus 25x plus 21. Okay. So the first thing you need here, you need some k values to plug in. So all of your possible rational zeros. Remember, those are your factors of a sub 0 over your factors of your lead coefficient. So remember, this is your a sub 0. Your a sub n is going to equal 1 for this one. All right, so that's going to equal, for 21, you have plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. Okay, those are all factors of 21. And for your lead coefficient of 1, you just have plus or minus 1, which you really don't need, so you're good there. Okay, so your possible factors. I mean zeros, I don't know why I said factors. Possible rational zeros is plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. All right, so we'll start with, and you can pick any one of those. You don't have to start with positive, negative 1. If you want to start with 7, you could. It wouldn't matter. So we'll start with x equals 1. I mean, not x equals 1, k equals 1. Why do I keep doing that? Okay, so when k is equal to 1, you have your 1. And remember, you want to write all your coefficients. So you have 1, 3, negative 25, 21. Okay, you get your first one, you bring it on down. 1 times 1 is 1. Add them together. 3 plus 1 is 4. 1 times 4 is 4. Add them together. Negative 25 plus 4 is negative 21. 1 times negative 21 is negative 21. Add them together. This becomes 0. Okay, so we know that 1 is a rational 0. Of f of x. Okay, so remember, this is your x to the third. This is your 3x squared. This is your negative 25x, and this was just your constant. Okay, all of those go down 1. So this becomes your x squared. This becomes your x, and this one becomes your constant. Okay, so we know we have 3, it's a degree of 3. So we have f of x is going to equal x minus, we'll call it x1. X minus, we'll call it x2, and x minus some unknown x3. Okay, we know one of them. So that means our f of x is going to equal x minus 1 times, now this goes to what we have to factor next. X squared plus 4x minus 21. Okay, now if you wanted to, you could keep going with, was it negative 1, 3, negative, you can keep going with all of those. But once it gets here, I'd factor it the old-fashioned way. It's just a whole lot faster. Okay, so factor x squared plus 4x minus 21 the old-fashioned way. Okay, so we know that x squared plus 4x minus 21, to factor that, we have to find two numbers that equal c, which is negative 21, and those same two numbers that add to equal b, which is 4. Okay, so for this one, 7 and 3 looks like it works. Oh, 7 and negative 3. 7 and negative 3 is negative 21. 7 plus negative 3 is positive 4. So this, you have f of x equals x minus 1, and this just becomes x plus 7 and x minus 3. Okay, so sometimes all you need is that one rational zero, and then you can just factor the other one whichever way you want to. All right, so you, like I said, you could have gone through and plugged in all the rest of them and kept doing synthetic division over and over, and it would have eventually reached that, but it's just a lot faster to just go ahead and factor it if you can the regular way. All right, so we know that your rational zeros are x equals, if you plug in 1, that all becomes 0. If you plug in -7, that all becomes 0. And if you plug in 3, that becomes 0. All right, so any questions on that one?
I think he just got like a little certificate.
All right. Go. Anyone still writing? Okay. Okay, so let's say if we go over the fundamental theorem of algebra. Okay, so let's say if you have some function f of x is a polynomial of degree n. And it could be 2, 3, 4, 5, 10, we have no idea. But it's some finite polynomial. Okay, we just know that it's bigger than 0. Then that function, that polynomial, has at least one 0. In the complex number system. Okay. Now it doesn't mean that it'll only have complex zeros, because let's say if you remember, a real number can be written as a complex number. Okay, so for example, if you have the number 2, you can write that as 2 plus 0i. Okay, where you have a real number written as a complex number. Okay, so let's say, for example, just to kind of put that to the test, f of x equals x minus 2. It has one 0. Which is x equals 2. If you make x equals 2, f of x is equal to 0. Okay, so what about f of x equals x squared minus 6x plus 9? It has two zeros. Remember, that's x minus 3 times x minus 3. So they're repeating zeros, but you still have 2. X equals 3 and x equals 3. Okay, so if you have, let's say, f of x equals x to the third plus 4x, if you factor out that x, and you have x squared plus 4, if you factor that x squared plus 4, okay, remember that's not a difference of squares, so you can't use that. But if you could probably use quadratic formula. You could use various other methods. So, okay, so you have x times x plus 2i, x minus 2i. Okay, let's say if you use quadratic formula. That's usually the go-to. Let's say x squared plus 0x plus 4. Okay, so that would give you your negative b plus or minus the square root of b squared minus 4ac. And that's the answer you would get. So you'd actually have x plus 2i, x minus 2i. Okay, so your zeros here, x equals 0, x equal negative 2i, because that will make that 0, and x equals positive 2i will make this one 0. Okay, so you have a degree 3, so you have 3 zeros. Okay, they're saying you just have to have at least one. Okay, now let's say if we have f of x equals x to the 4th minus 1. Okay, which is the difference of squares. So you have x squared minus 1 and x squared plus 1. Okay, now this is another difference of squares, which is just x plus 1, x minus 1. Okay, and this one, if you actually factor that out, you would get x plus I, x minus I. Okay, so these are kind of just quick examples of that one. All right, any questions on this one? All right, well, you might have to go back and kind of review complex numbers a bit. If you have any trouble, just let me know and I'll be more than happy to kind of go over them with you. Okay, quick note before we start our first example. If, let's say, a plus bi, which is your complex number, is a zero of a function, then so is its conjugate. Which is a minus bi. Remember the conjugate, you're just changing the sign in front of the, sorry about that. You're changing the sign in front of the complex number. Okay, so for example, if 2i is a 0, clean that, get a little more room. Then so is negative 2i. Because remember, this is just 0 plus 2i, and this is just 0 minus 2i. All right, any questions on this so far? Okay. All right, so let's say, for example, if we have, and I should have enough room to finish this on this page. Okay, so find the function that has an output of 16 when x equals 2 and has zeros 1 and 2i. Okay. Okay, so the general form for your f of x function is you're going to have possibly some lead coefficient of a. We don't know, it kind of depends on the function. Sometimes it's 1, sometimes it's other than 1. So you have some lead coefficient of a. Come on, there we go. X minus, we'll call your, well, instead of x1, I'll call it c1. X minus some 0, we'll call c1, times x minus some 0, we'll call c2, x minus some 0, we'll call c3, and it keeps on going until you reach some final 0. Okay, so this is your general form. Of an nth degree polynomial. And we only say nth degree because we don't know what that n is. All right. Okay, so for this one, we know that since 2i is a 0, so it's negative 2i. Actually, this should have been third degree. Well, probably figure that out. Since 2i is a 0, so is negative 2i. So if we have our f of x equals a, we know 2i and negative 2i are zeros. Clean that up some. There we go. So we know x minus 2i, x plus 2i. Okay, so we know those are zeros. And we also know that x equals 1 is a 0. So x minus 1. Okay, so they gave us all the zeros. So we know this is going to be a third degree polynomial. It's already a third degree polynomial, but we know it's going to have a lead coefficient, a lead exponent of 3. Okay, so now we want to find out what it is x equals 2. Okay, so we have our function. Once we have our zeros, we have our function. The only thing missing is that a. We don't know what it is yet. So all we have to do is plug in 2. Okay. Since x is equal to 2, plug it in to solve for a. Okay, so that's the only thing we don't have is that a. As soon as we plug in our 2, we'll have that. Okay, so we know that f of 2 equals a times 2 minus 2i. I mean, not 2 minus 2i, what am I looking at? Well, I guess you could factor that out first. You don't have to. All right. So it's probably easier to factor that first. Not factor, but distribute it. Okay, so we'll just make f of x equals, and we'll FOIL this out first. Okay, so that gives you x squared plus outer plus x2i minus x times 2i. And your last is minus 2 times I squared times x minus 1. Oops, sorry about that. Okay, so these two plus or minus cancel out. Yes. Oh, it was 2i4. Thank you. All right. So we know that I squared is equal to negative 1. Okay, so that means our f of x is equal to a times x squared. That becomes plus 4 times x minus 1. Okay. And then from there, we can just use the FOIL method again. Okay, so f of x equals a times x squared times x is x to the third. Your outer is negative x squared. Your inner is 4x. And your last is negative 4. Okay. So that's a little bit easier to find f of 2 than when it was in the previous form, because then now you don't have to deal with the 2 i's and negative 2 i's and all of that. Okay, so f of 2 is going to equal a times x to the third, we'll say 2 to the third, minus x squared, which is 2 squared, plus 4 times 2, minus 4. Okay, and we know just from the beginning that output of 16 means this is going to equal 16. Okay, just from where it says output of 16. When x is equal to 2. All right, so that means just kind of ignoring that because we don't need that anymore, so we're just focusing on those two. You have a, 2 to the third power is 8, minus 2 squared, which is 4, plus 8 minus 4 equals 16. Okay, so you have negative 4, which is negative 8, positive 8. So you have a times 8 equals 16. Or 8a. You write it the traditional way. 8a equals 16. Divide both sides by 8. You get a equals 2. Okay, so now all we have to do to solve this is just plug our a in there, and we have our answer. Okay, so f of x is equal to, sorry for the tight fit down here, x minus 2i, x plus 2i, times x minus 1. Okay, so that would be your, straighten that up, your function. All right, so any questions on that one? I know not the shortest problem in the world, but I tried to find the easiest possible way to explain it, but some problems are just naturally long. This happens to be one of them. All right. Okay, we'll do one more example, and then I'll let you out of here. Excuse me. All right, so let's say, I'm getting ready to shut off here.